Potential energy of a particle of mass m is given by u of x equal to E naught when the position is in between 0 to 1. When the position of the mass is in between 0 to 1, its potential energy is E naught. When its position is beyond 1 meter, its potential energy is 0. That is what is given. For lambda 1 and lambda 2 are the de Broglie wavelengths of the particle. When 0 less than 1 equal to x less than or equal to 1 and x greater than 1. So, the de Broglie wavelength corresponding for the particle of mass m when it is in this position is lambda 1, and when it is in this position, that is beyond 1 meter, the de Broglie wavelength is lambda 2. That is what is the data. If the total energy of the particle is 2 E naught, then ratio lambda 1 by lambda 2 will be. So, that is what is given to us. So, the total energy is 2 E naught. Kinetic energy is total energy minus potential energy. Okay? Kinetic energy is total energy minus potential energy. So, kinetic energy K1 is 2 E naught minus E naught when the positions are between 0 and 1. When the position of the particle is between 0 and 1, that will be equal to E naught. So, K1 is equal to E naught. K1 is equal to E naught. So, that implies by de Broglie's hypothesis, we know lambda 1 is h by root of 2m K1. So, lambda 1 is h by root of 2m E naught. This is equation 1. Similarly, if you go to lambda 2, kinetic energy is total energy minus potential energy. Now, total energy is 2 E naught. Always total mechanical energy of the system is always conserved. So, 2 E naught it is. However, the potential energy is 0 when the particle is beyond 1 meter. So, kinetic energy K2 is 2 E naught, implies K2 is 2 E naught. Now, lambda 2 is h by root of 2m K2, which is h by root of 2m into 2 E naught. K2 I have substituted. So, what I am going to get? Lambda 2 as h by root of 2m E naught into 2. This is equation 2. So, the ratio lambda 1 by lambda 2, if you see, h by root of 2m E naught is common and it gets cancelled, and what remains is 1 by root 2. So, it is root 2 is the ratio, which is option C.